Sensation and perception. So this unit is all about how we take in information through our senses and how we make sense of what that information is in our mind. So by definition, a sensation is how we detect, convert, and transmit raw sensory information from our senses, our seeing, smelling, touching, tasting, hearing, feeling, to the brain. Our perception is how we select, organize, and interpret the sensory information that's received from our brain. So first we have a sense, and then we perceive or make sense of what we just sensed. So if you take a look at this picture, this gives us a good diagram about how information like light and sound enters into our senses, and we either hear it, see it, touch it, taste it, feel it, and then our brain has to make sense of that information. For example, our occipital lobe is in charge of our vision, and so we take in that information as light waves hit it, and then we can make sense of what that is. When we process through our five senses, there are certain things that are happening in order for us to receive that information. For example, for our vision, there's light waves that make sense of the information, and we will talk more about that in a little bit. Our audition is known as your hearing, which is based on sound waves and hair cells in your cochlea. Olfaction is your sense of smell, which has to do with mucous membranes in the olfactory epithelium. And gustation is your sense of taste, which has to do with molecules that exist on your tongue. And then your body sensations are a combination of different stimuli that help you feel something. So you need to know the difference between bottom-up and top-down processing. Bottom-up processing occurs when we have raw sensory data where information processing begins at the top of your brain with raw data that, well, at the top, meaning raw data is sent up to your brain for higher level analysis. Top-down processing is the exact opposite. That's where we start with processing at the top of your brain, and then we work our way down to those schema-driven processes. So you go down to what you think it might be. Psychophysics is the field that studies the link between the physical characteristics of a stimulus and how we psychologically perceive them. Two parts of psychophysics are absolute threshold and difference threshold. Absolute threshold is the smallest amount of a stimulus you can reliably detect. Like how far away can you see a dim light in the dark? Your absolute threshold would be how far you can go away to see that. Difference threshold, which is also sometimes called Weber's law, is what type of changes, what differences need to be made in order for you to notice there's been a difference. For example, let's just say it's a really cold day outside and you start out the day wearing your jacket or your coat. The difference threshold would be how much does the temperature outside need to change for you to say, I don't need this coat anymore? Is it 20 degrees? Is that the difference? Is it 10 degrees? Here are some different absolute thresholds of the senses. Like I said, with vision, how far away can you see a candle flame on a clear, dark night? About 30 miles. Hearing, you can hear a watch ticking from about 20 feet away in a quiet room, and etc. Sensory adaptation occurs after a person has had constant exposure to a stimulus. Their sensation of that stimulus usually fades. For example, you go to a restaurant, as soon as you walk in the door, you're like, oh my gosh, it smells so good in here, I can't wait to eat. But the longer you are in the restaurant, your senses adapt to that smell, and you no longer smell the food the way you did when you first walked in. The gate control theory of pain says that the spinal cord has a neurological gate that blocks pain signals from reaching the brain. What happens is if a person stubs their toe? They immediately go to rub that area. They're unconsciously trying to close that gate that exists in their spinal cord so that they will no longer feel the pain. And again, this is a hypothetical gate. If the gate is open, you feel pain. If it's closed, you don't feel pain. Phantom limb pain occurs with 2 out of 3 combat veterans who have had amputated limbs. And it doesn't have to just be a combat veteran. It could be anybody who's maybe had their leg or arm or any part of their body amputated. Occasionally what will happen is those nerve fibers in that missing limb will feel activated, and they might try to reorganize themselves, and that person will suddenly feel like they have the sensation of that missing limb back again, which can be very devastating because if you haven't had both of your legs, for example, and suddenly you feel sensation like your legs are there, you might try to get up and walk, and then you get hit with the reality that they don't exist. When it comes to our vision, vision is based on light hitting the eye. Light is a form of electromagnetic energy that's going to move in waves. The function of the eye is to capture those light waves and focus them at the back of your eyeball so that your eye can make sense of the image that hits it. In your eyes, there are rods and cones. Rods are cones are densely packed. They're in the retina and they are cones. They start with a C. They provide color vision. They help you see fine details. Rods are the exact opposite. They are sensitive to dim light and they help you see in black and white. When it comes to color blindness, there are 3 different ways you could be color blind, or there are 3 ways you can see color. There's trichromatic vision, which is normal color vision, where you see color the way everybody else around you does. Monochromatic color vision is somebody who is totally colorblind and can't see any color. It's less common. And dichromatic color vision is partial color blindness, when people have to discriminate between 2 colors, like red and green or yellow and blue. Dichromatic color blindness is more common in males, so it's assumed that it's a sex-linked trait. The opponent process theory of color vision tells us that color perception results from 3 systems of color opposites, so blue, yellow, red, green, and black and white. If you just do a task for a few seconds, if you'll stare at that black dot that's in the middle of that flag just for about 20 or 30 seconds. Then look at a blank wall around you. And what do you see? You should see the American flag with the right colors on the white wall. That is because of the opponent process theory. Audition is our ability to hear, which results from the movement of air molecules in waves. Sound waves can vary in wavelength and amplitude, which impacts the pitch and loudness of something. As you can see here, the outer ear, this kind of gold part, contains several parts of the ear that are important for hearing. The middle ear is the blue part, contains other areas as well. And the innermost pinkish part contains the most important parts, the cochlea, which is a key area for hearing. The loudness of sound is often measured in decibels. Anybody who's exposed to constant noise above 90 decibels can cause permanent nerve damage and irreversible hearing loss. So if we look at this chart, If you are constantly listening to a subway or train or at a rock concert, jet plane, space shuttle launch, all of those things are above 90 decibels. Even heavy traffic is right there at 80. So you can kind of take a look at some of the things that, can cause you to have nerve damage in your ear. The next sense is olfaction, which is your sense of smell. And receptors for smell are located in the olfactory epithelium. Olfaction is the only sense that's not processed through the thalamus. Everything else is processed through the thalamus, but this is processed in the olfactory receptors. Gustation is your sense of taste. All of your taste buds are located on the surface of your tongue. There are different types of taste. The four primary tastes are sweet, sour, salty, and bitter, all located on different areas of your tongue. And umami, which is the fifth basic taste, also called the savory taste, many people also believe in. Many people like food not only based on taste, but also on odor, texture, and temperature. Some people are taste sensitive and are super tasters. And when they taste things, they taste them more intently. Acupuncture is a Chinese method of pain reduction. Research shows that participating in acupuncture can stimulate nerve cells and activate the hypothalamus to reduce endorphins, which we know endorphins are like the body's natural painkiller. There are various body senses as well. The vestibular sense is your sense of balance, your sense of movement and position. Your vestibular sense works because you can sense where you are. If everybody stood up right now, they could stand on one leg. They could activate their vestibular sense and sense their body. Kinesthesia provides our brains with information about posture, orientation, and movement. The vestibular and kinesthetic senses are often confused, but the vestibular sense is our sense of balance, while kinesthesia is knowing where our body is located, our brain receiving the information about our posture, orientation, and movement. Here's the same task. If you were able to stand during the vestibular sense and test it out by standing on one leg, you could also practice kinesthesia. This time, try standing on one leg in a safe place, but with your eyes closed. If you do that, notice quickly that it's harder to do because now your brain is having trouble because you aren't seeing what's going on. It's having trouble sensing where your body position is. Figure ground is our tendency to organize things in our visual field into objects or figures that stand apart from their backgrounds. So if you take a look at the picture, you should see fish, you should see birds. In the black part, you see birds. In the white part, you see birds. In the black part, you see fish. That's because your visual field is trying to make those things into objects. Perceptual learning is our increased ability to use sensory information. If you lose one of your senses, others will try to overcompensate. When it comes to our understanding of perceptions, an illusion is a false or misleading perception, such as the horizontal vertical illusion. If you look at these two lines, one of them looks longer, right? When in reality, it's an illusion. They are both the same length. The law of pragnance says that our visual perceptive system likes to see something as truly developed. So something like a broken circle, we can see as a completely filled circle. If you take a look at this picture, you should see a Dalmatian, because when our eyes see something in black and white, it looks like it has legs, then we're going to try to make out a dog. Pattern perception is also called form perception. It's our ability to recognize and identify faces, words, and shapes as such. If you take a look at this pattern perception, black and white, there's a face, it's a cow. Many people can't see that though. So when it comes to selection, we are able to direct our attention to a certain place. Selective attention has to do with filtering out and only attending to important sensory information. You are able to have selective attention when you can watch your favorite television show even though people around you are talking. Feature detectors are specialized neurons in our brain that only respond to certain sensory information. Habituation is our brain's tendency to ignore environmental factors that remain constant. So anything in our environment that stays the same, we tend to ignore. The cocktail party effect, or phenomenon, is our ability, if we are in a large group of people or at a party, like a cocktail party, we can focus our attention on a single talker, even though multiple people are talking around us. It's a form of selective attention. And if you were in a party and you heard somebody mention your name, chances are you would tune into that conversation and not focus on the conversation you're having because you heard your name mentioned. Depth perception is our ability to perceive three-dimensional space and accurately judge distance. If you look at this comic, this guy is saying, I don't have a good sense of depth perception. Is there somebody standing on the corner, or is there a little man in your head? Obviously, it kind of looks like there's a man in her head, but clearly that wouldn't be likely. The visual cliff experiment was an experiment done with babies to see if they recognize depth perception. And according to the visual cliff experiment, infants will hesitate to crawl over glass when they have learned depth perception. They'll know, I should stop, I don't want to fall. If they haven't learned depth perception, of course, they're just going to keep on crawling. When it comes to depth perception, you have both binocular and monocular cues. Binocular cues are cues that involve both of your eyes, or your ability to see things using both of your eyes, whereas monocular cues involve one of your eyes. Retinal disparity has to do with the separation of your eyes and how your eyes both fall on two different images, or different images fall on both parts of your retina, whereas convergence says that when an object is closer to you, the eyes will converge and turn inward in order to see and visualize it. An extrasensory perception is a type of psychic ability that goes beyond the senses. Research for ESP, or extrasensory perception, is often criticized because it lacks control and repeatability. There are different types of ESP. It's one of those things that could be considered a pseudoscience. It's not really grounded in psychological fact. And that's everything you guys need to know about sensation and perception.